In module 3, another most important experiment which is known as digital to analog converter. The digital to analog converter. Digital to analog converter by using a interfacing. So here it is a hardware parts, Arduino board we can use here. Arduino UNO board it is. In this case, Arduino board which is connected to the 16 into 2 LCD voltage liquid crystal display. So these are the important pins. Just you are observing this from the Arduino board output. This output pin is processed through this LCD output, and another pin is known as ground. That ground is connected to the another ground of that LCD board. Similarly, SCL is a pin serial clock line, and VCC is the input reference voltage. Here we are selecting plus 5 volts, and ground is there, another ground for input it is, because two ground points are there. One ground is for display and another ground for the input. So we can connect one 10 k ohm potentiometer here. By varying this resistance in the Arduino board, the output voltage will be changes. So it is most useful parameters. So by using this digital to analog converter, what are the usefulness in the real time applications? For example, you can select so many control systems are there in embedded systems. By using these embedded systems, we can use as the motor controller, AC or DC. You can control through this embedded system. Control for brightness, LED display is there. So many display devices are there in real time. We can control this brightness by using this digital to analog converter. And another one is LED control as well as audio amplifier. Audio means you can hear the sound. This also you can control with the help of this equipments. Then another important application is video encoder. Video encoder, you are already familiar about MP3, and so many applications are available in case of your Android mobile. Similarly, another important application is data acquisition systems for digital communication system. These are the minimum number of applications are useful for digital to analog converter. Hence, we are conduct the experiment for interfacing by using Arduino UNO board in the embedded system. Then another important parameter for hardware calculation is most important. We have to calculate, select 12 bits or 16 bit, 12 bit resolutions. Minimum integer value is 0 to 4096. The maximum is 4096 the integer values, and you can select the maximum reference voltage is 5 volts. Then these are most important to calculation for the output, how much voltage you will get. So output voltage can be calculated, reference voltage divided by resolution into digital values. Put the digital values maximum, reference voltage we are selecting plus 5 volts divided by resolution 4096 is the resolutions, and 2048 for the digital values. So by using this, you can calculate at maximum 2.5 volts. 2.5 volts maximum will obtain from this display. In this way, we can calculate the hardware devices and amount of voltage required and how much amount of voltage will observe on LCD board. So these are the important input information before writing the code of this interfacing of digital to analog. So in this case, just we are writing the code digital to analog converter. So important parameters you should be declared in the C language. You are already learned in lower semesters. So I am using here hash include wire.h. This is one library functions. And another function include liquid crystal.h, keeping all these things in a header file. And define MCP 4725 is the device 0 into 61 address for changing. And another liquid crystal LCD. These are the pins to display. What are those pins? 2, 3, 4, 5, 6 and 7 for LCD display pins. So unsigned integer, you can declare it analog to digital converter. Byte buffer, you can select it 3. Buffer means store the informations at the beginning 0, 1, 2, 3 like that. So and begin that setup, wide setup, and starts its operations. Wire dot begin, then you can declare, and LCD dot begin, you declare the pin of LCD 16, 2. LCD dot print circuit digest, and keep the delay between the blinking of these LEDs. Delay you can keep 1000. Then uh, seconds, then LCD dot clear, and similarly LCD set the cursor at the beginning 0, and next is 1. So this process of writing the C language, it is continuous. You can go through this one by one, then we will complete the C language. So it is so very simple. First you know the hardware, it's a calculation part. Rest of the things you can utilize the C language skill, writing program writing skill, then automatically you can able to write this coding. So this entire code I already sent to you through the mail. Just you can download it and you can read one times, and whatever the code it is there, it is dumped into the embedded software and you can execute it. The results are displayed on the LCD code. In this way we have to write the C program. It is continuous. I already sent this code to your mail address, so you can download it and you can just read one time, then you automatically know about this digital to analog converter. So in module 3, another important experiment which is known as keyboard interface or keypad interface. It is also one of the important experiment point of view as well as theoretical point of view. Here we are going to learn how to interface the keyboard. Keyboard means several types of keyboards are there, and ATM keyboards are also there, then computer keyboards are also there, several types of keyboard. But the philosophy of this keyboard interface is same as the keypad interfacing. See, you can observe this keypad. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, star, 0 and hash. Total number of row, number of columns 1, 2, 3. 3 columns are there. I am declaring it is 1, 2 and 3. Similarly, number of rows, 4 rows, 1, 2, 3, 4. I am declaring as A, B, C and D. It is a keypad informations, number of rows and number of columns. These are most important before interfacing with Arduino board. I will look at this Arduino board, Arduino UNO board. Input Arduino UNO board 13 I am connecting pin number 1, 12 I am connecting pin number 2, 11 I am connecting 3 and 10 I am connecting A, 9 B, 8 C and 7 D. Likewise we are taking the communication between from keypad to interface. Similarly we will go through this LCD. Whatever the results, if you want to observe that LCD is also most important, this display. So it connected these pins are D0, D1, D2 and D3. These are the total hardware arrangement. This arrangement is also most important things. You should know about all the hardware, then only you are able to interfacing and communicating with the help of softwares. You may use it either C language or any one assembly language, microcontroller can use it, then you can find out the result. So important observation for this experiment is, so this type of keyboard you can observe through all ATM machines as a keypad. Calculate the number of rows, most important, calculate the number of rows and number of columns. And second important point is keypad uses the matrix system. Always remember number of rows and columns. It is always use the technique of matrix system in order to work. In order to work, this is like a matrix. Another important point for this experiment is keypad has 12 buttons. You can count the number of buttons. It has 12 buttons, total 3 columns and 4 rows. You should estimate all these parameters. These are helpful for writing the programs. Therefore, final what you are going to know that total number of pins is equal to number of rows plus number of columns. This is the entire things we are estimating from the hardware part. Later part we are going to introduce about the based on this hardware we are interfacing this keypad with the Arduinos and LCDs. Then we are start writing the code. Then it is communicated. If it is everything is right, then you can communicate and pass the information. Whatever information you will press with the help of keyboard, that is passes, and results you can observe on LCD board. Whatever the results, whether it is correct or not, all the results are displayed on the LCD board. In this way, we can interface keyboard interface or keypad interface with the help of Arduino UNO.